Good morning my dear student, and today we will see the abnormal colligative properties and one top factor. Already we have studied the colligative properties, vapor pressure depression, then the elevation in boiling point, depression in freezing point and osmotic pressure. Now various relations of the colligative property holds good in the dilute solution only when there is a no change in the molecular state. Molecular state means as we add the solute in solvent, then there is a formation of solution. There is a formation of solution. In solution, the solute number of solute is remains the same. Number of solute is remain the same. Then the colligative properties we can relate with the concentration of the solution, but sometimes what happens, the solute reacts with the solvent or the solute reacts with itself and it either dissociate or associate, means two molecules gives the one molecules or the one molecule gives the two molecules. At that time the molarity or the number of particle in the solution decreases and colligative property will not changes with the proportion. And in case of the total number of particles of the solute changes in solution, if solute and solvent, colligative property is also changes according to the number of particle changes in the solution. And sometimes what happens, the one type of the solute gives association, means it combines with the second molecule of the same solute and it is called as the association, and due to this the colligative property decreases. Okay. Then one top factor decides the by how much factor the colligative property decreases or increases. So let us see, the two changes occurs mainly. These changes are responsible for the colligative property change or the number of particle change by dissociation. When substance is an electrolyte, the number of particles increases in the solution and the colligative property increases accordingly. In case of dissociation, suppose one molecule of solute A, suppose one molecule of solute A dissociate to give n ions, for example A dissociate because A is an electrolyte and it dissociate to give n number of ions, and we can denote it by B. Alpha is the degree of dissociation. So if the concentration, initial concentration is 1 mole, okay, initially means before the dissociation the concentration of the electrolyte A is 1 mole and the number of ions is 0 because no dissociation is taking place. After dissociation, the concentration of A decreases by alpha. So concentration will be the 1 minus alpha mole, and the concentration of the ions form becomes the n into alpha, okay, after dissociation. The total number of moles present in solution we can determine total number of particle, that is total number of molecules, moles present in solution we can calculate is equals to, now when we add the solute A in the solvent, then after dissociation, if that species is electrolyte, then it dissociate, and after dissociation there is a N, B is present and some amount of A is also present, then the total amount of A present is 1 minus alpha plus total number of particles due to dissociation, it is N alpha, and we can solve this. So, we get the 1 plus N minus 1 into alpha. These are the particles, total particles present after dissociation, and it is called as the Hoff factor. So, we can write here as a Hoff factor is equals to, it is denoted by I and is equal to 1 plus N minus 1 into alpha, and it is always greater than 1 if N is equal to 2. It means if that electrolyte dissociate into the two particles, right, into the cation and anion, then this I is always greater than 1, and from that, from equation I is equal to 1 plus N minus 1 into alpha, we can write the alpha, that is the degree of dissociation, is equal to Hoff factor I minus 1 upon N minus 1. N is the number of particles formed after dissociation. Then second factor which changes the colligative property is by association. By association. When the substance undergo association, association means what? When two solute particle combine to give the one solute particle, then the number of particle decreases in the solution, and consequently the value of colligative property is also decreases, because the colligative property is proportional with the number of particles in solution, In case of association, the number of particle decreases in solution, and hence the colligative property is also decreases. While we have seen earlier, that is the number of particle increases due to dissociation, and hence the colligative property is also increases due to dissociation. Now, association of molecule is given by the example. For example, see the acetic acid CH3COOH. If we take the 2 mole of acetic acid, then it get associated by the hydrogen bonding. Then we can show it as a CH3COOH twice. This is called as association. We can show very clearly here CH3 carbon oxygen double bond, then OH. This is one molecule. Second molecule oxygen here, then CH3O and H molecule. Hydrogen bonding is present in between the two molecules, and that is why these two molecules of the acetic acid is associated. Means the colligative property is decreased by 1/2, and the molecules of acetic acid dimerize in benzene due to the hydrogen bonding. If the solvent is benzene, then it get dimerized likewise. It generally happens in the solvent having the low dielectric constant. Okay. As already we have seen in case of the association, suppose n molecules associate, suppose n molecules associate to form one bigger molecule, one giant molecule, and alpha is the again degree of dissociation, sorry, degree of association here, degree of association. So we can show it as a n number of A molecules. It is in equilibrium. If we mix with the solvent, that is A n, we will get. So initially the concentration of A solute is 1 mole. So initial concentration, initially 1 mole is the concentration of A molecule, and initially there is a no association, so concentration will be 0. After association, 1 minus alpha mole will be the concentration of A, and alpha upon n will be the concentration at equilibrium, or after association we can say. So the total number of moles of particle in the solution we can write total number of moles of particles in solution is equals to, that is one top factor, 1 minus alpha plus alpha upon n, and we can solve this. We get the 1 plus 1 upon n minus 1 into alpha, and this is nothing but the one top factor, and it is denoted by R, and this is less than 1, this I will be less than 1, this is less than 1 if n is greater than or equals to 2. Okay. And from this equation, that is I is equal to 1 plus 1 upon n minus 1 into alpha. Alpha is the degree of dissociation, and from this value we can determine the alpha. So alpha is equals to I minus 1 upon, बिकॉज अल्फ़ा मल्टीप्लाइड है यहाँ पे, तो आई ये जो है ये प्लस इस साइड जाएगा इज इक्वल टू के, तो माइनस हो जाएगा आई माइनस 1 अपॉन ये जो टर्म है ये मल्टीप्लाई है अल्फ़ा को, तो ये डिवाइड हो जाएगी यहाँ पे आने के बाद, तो डिवाइड होने के बाद क्या होगा, या 1 अपॉन n माइनस 1, ये हो गई डिग्री ऑफ डिसोसिएशन की वैल्यू इफ़ द सोल्यूट पार्टिकल्स आर एसोसिएटेड. ओके, so from this we can write the one top factor very clearly. The one top factor, the normal value of colligative property one top factor. So normal value of colligative property is proportional with the number of particles. As already we know, the number of normal value of colligative property is proportional with the number of particles of solute. एंड एबनॉर्मल वैल्यू ऑफ कॉलिगेटिव प्रॉपर्टी, ये नॉर्मल वैल्यू हुई, अगर एसोसिएशन और डिसोसिएशन नहीं होता है तो नंबर ऑफ पार्टिकल से प्रोपोर्शन में होती है. द वैल्यू ऑफ कॉलिगेटिव प्रॉपर्टी is proportional with the number of particles of solute after dissociation or association. After dissociation or association, right? The ratio of two values, if we take the ratio of two values, that is abnormal value of colligative property upon the normal value of colligative property these two properties are different because the abnormal value of colligative property may be less if the association is taking place than the normal value of colligative property, and the abnormal value of colligative property may be more if the dissociation is taking place in the solution than the normal value of colligative property, and these will get the I, and I is nothing but our one-off factor. So, from this we can write one-off factor, that is I is equals to pi observed upon pi theoretical. Theoretical means normal osmotic pressure, and pi observed means the observed osmotic pressure due to association or dissociation. If there is a no association and no dissociation, then I is equal to 1, that is one-off factor, I is equal to 1. But if there is association or dissociation, then I value is not 1. And again we can write the lowering in vapor pressure, delta PV observed upon colligative property lowering in vapor pressure, that is theoretical value, or we can write the elevation in boiling point, delta TB observed upon the delta TB theoretical, and we can write same here for the depression in freezing point, that is delta TF again observe upon delta TF theoretical, okay. And actual number of particle in solution, or we can write here as the, because the colligative property is proportional with the number of particles, so the actual number of particles in solution upon the number of particles taken, number of particles taken, that is the normality or molarity, how much mole we have added. But after addition in the solvent, there may be the association or dissociation, and that is why the actual number of particles either decreases or increases, and hence the I value may be more or less, okay. So, it is one-off factor and the colligative property relation. Second term is, next is the abnormal molecular weight. As we know, the colligative property is inverse to the molecular weight. Already we have seen while studying the colligative property. The colligative properties colligative property is directly proportional to the 1 upon the molecular weight. 1 upon molecular weight. So, the normal colligative property is inverse to the normal molecular weight, and abnormal colligative property is inverse to the abnormal molecular weight. So, from that we can write here the abnormal colligative property upon the normal colligative property is equal to the molecular weight. Now see, abnormal colligative property is inversely proportional to the abnormal molecular weight. So, here will be the abnormal molecular weight, and the normal colligative property is inverse to the molecular weight, that is the normal molecular weight. Okay. And from this we can determine the abnormal molecular weight of the solute, and is equals to, we can write here from the above expression, 1 plus n minus 1 into alpha is greater than 1 in case of dissociation. Okay. And 1 plus 1 upon n minus 1 into alpha is less than 1 in association. In case of the Hoff factor is known, that is I, if you know the I, the various colligative properties would be given by if we know the I value, if we know I, if I is known, the various colligative property will be, for example, the depression in freezing point delta Tf is equal to I into K of m, okay. And delta Tb will be I, that is the Hoff factor multiplied into the ebullioscopic constant into the molality. Then again this is delta. Okay. Then vapor pressure pi v is equals to INRT. And the lowering of vapor pressure, that is P0 upon P upon relative lowering of vapor pressure, is equal to Hoff factor into the mole fraction of the solute, that is XB, where m is the molarity of the solution, m is what? Molality of solution, and I into m is sometimes referred to as the effective molality, sometimes referred as effective molality or the colligative molality or colligative molality. I into m, it is effective molality or colligative molality. So, mi or the I into m is equal to, we can write it as a effective molality, that is mi. So, the colligative property, that is the depression in freezing point delta F, will be the Kf into mi, prefix I here to the molarity. Then delta Tb we can write it as a ebullioscopy constant, that is Kb into mi likewise. So ये था abnormal molecular weight and the relation between the Van 't Hoff factor and the colligative property. If we know the Van 't Hoff factor, then we have to multiply it in the formula of colligative properties determination. So if you like my video, then please share, subscribe and press the bell icon, so whenever I add the new video you will get the notification. Thank you so much.